Take a look at the shirt you're wearing. There's a good chance it contains cotton, maybe polyester, maybe a blend of both. But over the last decade, another material has quietly exploded in popularity: bamboo. Today, bamboo clothing is everywhere. T-shirts, socks, underwear, pajamas, athletic wear, even luxury bedding. Manufacturers describe it as softer than cotton, cooler than polyester, naturally antibacterial, eco-friendly, and one of the most sustainable fabrics on Earth. Consumers love it. The global bamboo textile industry is now worth billions of dollars. Every year, millions of people buy bamboo clothing, believing they are wearing something close to nature, something made directly from a fast-growing plant, something greener than traditional fabrics. But here's the strange part. Most bamboo clothing doesn't begin in a textile mill. It begins in a chemical plant. And the bamboo fibers many consumers imagine never actually survive the manufacturing process. In fact, if you could follow a bamboo stalk from the forest to the shirt hanging in a store, you would witness one of the most dramatic transformations in modern manufacturing. The plant is chopped into pieces, cooked, dissolved, converted into a thick chemical solution, forced through microscopic holes and rebuilt into entirely new fibers. The process is so complete that some textile experts argue the final product isn't really bamboo fiber at all, it's regenerated cellulose, a material that started as bamboo but became something entirely different. And that raises an uncomfortable question. If bamboo clothing is made from bamboo, why does it require a chemical process similar to the one used to manufacture rayon? The answer lies inside the plant itself, because bamboo is one of the fastest growing plants on Earth. Some species can grow more than 3 feet in a single day. It requires little fertilizer, very little irrigation, and unlike trees, it can regenerate after harvesting without being replanted. On paper, it looks like the perfect, sustainable material. Yet turning a hard wooden stalk into fabric soft enough for a baby blanket requires a process most consumers never see. A process involving forestry, chemistry, textile engineering, global supply chains, and one of the biggest marketing debates in the fashion industry. The label says bamboo. The factory tells a much bigger story. And to understand that story, we have to start in a bamboo forest. Because everything begins with a plant that grows faster than almost anything else on Earth. Long before bamboo became a fashion trend, it was already one of the most useful plants on Earth. For thousands of years, people used bamboo to build houses, bridges, scaffolding, furniture, paper, musical instruments, fishing tools, even water pipes. Entire civilizations grew alongside it. In parts of Asia, bamboo was so deeply woven into daily life that it became known as the plant of 1,000 uses. And unlike most building materials, bamboo had one extraordinary advantage. It could grow back incredibly fast. A pine tree may take decades to mature, an oak tree can take generations. But bamboo operates on a completely different timeline. Some species can grow more than 1 meter in a single day. Certain bamboo forests reach harvestable size in just 3 to 5 years. That speed would eventually attract the attention of an entirely different industry: textiles. Because as global demand for clothing increased, manufacturers began searching for alternatives to traditional fibers. Cotton required enormous amounts of water. Synthetic fibers depended on petroleum. Forests used for rayon production often required decades to recover. Bamboo appeared to offer a solution: fast growth, high yield, renewable harvest cycles, and vast plantations already existed across China and other parts of Asia. On paper, it looked almost perfect. But there was one problem. Bamboo wasn't soft, not even close. A mature bamboo stalk is essentially a giant tube reinforced with strong cellulose fibers and lignin. The same structural compounds that allow the plant to stand upright. The same compounds that make it useful in construction. The same compounds that make it completely unsuitable for clothing. You couldn't simply harvest bamboo, spin it into yarn, and make a t-shirt. The plant was far too rigid, far too woody, far too tough. Something had to change. But before that transformation could happen, the bamboo first had to be harvested. The process begins in vast bamboo plantations. Some stretch across entire mountainsides. Others cover valleys that seem to disappear into the horizon. Workers identify mature culms, the technical term for bamboo stalks, that have reached the ideal age. Too young and cellulose content remains lower. Too old and fiber quality begins to decline. Most textile-grade bamboo is harvested between 3 and 5 years after emerging from the ground. Unlike trees, bamboo is not uprooted. The stalk is cut near the base. The underground rhizome system remains alive. Within months, new shoots begin emerging from the soil. This natural regeneration is one reason bamboo gained its reputation as a sustainable resource. Once harvested, the stalks are bundled and transported to processing facilities. And this is where the first major transformation begins. The bamboo arrives looking like construction material, long green poles, hard enough to support weight, strong enough to build structures. Nothing about it resembles fabric. Massive industrial chippers reduce the stalks into small pieces. Rotating steel blades tear through the bamboo. The long poles become chips. The chips become fragments. Thousands of kilograms can be processed every hour. The material then moves through cleaning systems. Dust, leaves, dirt, foreign matter. Everything must be removed. The goal is purity. Because what manufacturers really want isn't the bamboo itself. It's something hidden inside. Cellulose. Cellulose is the most abundant organic polymer on Earth. It forms the structural framework of plants. It exists in trees, cotton, hemp, flax, and bamboo. But inside bamboo, cellulose is trapped within a complex structure of lignin and hemicellulose. Imagine reinforced concrete. The cellulose acts like steel reinforcement. The surrounding materials act like cement. To reach the cellulose, everything else must be broken apart. And that's where the story takes an unexpected turn. Because this isn't a textile process anymore. It's a chemical extraction process. The bamboo chips enter massive digesters, gigantic pressure vessels that resemble equipment found in paper mills. Inside, heat and chemicals begin dissolving the components surrounding the cellulose fibers. Hour after hour, the hard bamboo structure breaks down. The rigid plant slowly loses its identity. The stalk that once stood in a forest begins turning into pulp, a wet, fibrous mass that bears little resemblance to bamboo. And here's where the story flips. Most consumers imagine bamboo clothing starts with bamboo fibers. But at this stage, manufacturers aren't trying to preserve the original fibers. They're trying to isolate the cellulose itself. Because the next step doesn't involve spinning bamboo into thread. It involves dissolving it completely. The bamboo that entered the factory as a plant is about to become something entirely different. And once that transformation begins, there is no going back. At this point, the bamboo no longer looks like bamboo. The towering green stalks that entered the factory have been reduced to a damp, pale pulp. Most people would assume the next step involves spinning those fibers into thread. That's how cotton works. That's how wool works. That's how most natural fibers become fabric. But bamboo clothing follows a completely different path. And this is where the biggest misconception begins. Because the soft bamboo shirt hanging in a clothing store isn't usually made from bamboo fibers. It's made from bamboo cellulose. And to get there, the cellulose must first become a liquid. The pulp enters chemical processing tanks, massive stainless steel reactors capable of holding tens of thousands of liters. Inside these vessels, the cellulose is treated with sodium hydroxide, also known as caustic soda, the same industrial chemical used in soap manufacturing and paper production. The reaction changes the structure of the cellulose. It becomes more reactive, more accessible, easier to transform. But the real conversion happens next. The treated cellulose reacts with carbon disulfide, a chemical that converts the material into cellulose xanthate. This step is crucial because cellulose itself doesn't dissolve easily. Cellulose xanthate does. The material is transferred into mixing tanks where it combines with additional chemicals and water. Slowly, the solid pulp disappears. The fibers vanish. The structure of the original bamboo is completely broken down. What remains is a thick, amber-colored liquid, viscous, sticky, almost resembling honey. The textile industry calls this substance viscose. And this is the moment that surprises many consumers. Because there are no bamboo fibers left to spin. The original structure of the plant is gone. The bamboo has effectively been dissolved. The product is now a chemical solution. And yet somehow this liquid will soon become fabric. The viscose solution isn't ready yet. It must mature. Factories store it in aging tanks for several hours, sometimes longer. Temperature, viscosity, chemical composition. Everything is monitored carefully. If the solution is too thick, fiber production becomes difficult. Too thin and fiber quality suffers. The process requires precision, because the next stage determines the quality of every future shirt pair of socks and bedsheet. The viscose is pumped through filters that remove microscopic impurities. Even tiny particles can damage the final fibers. After filtration vacuum systems removed trapped air bubbles, air pockets could create weak points. Uneven texture, production defects. Everything must be uniform. Only then does the most fascinating part of the process begin, the spinning stage. Despite the name, nothing is being spun yet, at least not in the traditional sense. Instead, the viscose is forced through spinnerets, metal plates containing thousands of microscopic holes. Think of a shower head. Now imagine each opening being thinner than a human hair. High-pressure pumps push the liquid through these openings continuously. As the viscose emerges, it enters chemical baths containing sulfuric acid and other compounds. And suddenly something remarkable happens. The liquid solidifies, almost instantly. The dissolved cellulose reforms into long, continuous filaments. The process is called regeneration, because the cellulose isn't being created, it's being rebuilt. The bamboo cellulose that was dissolved earlier is now returning to solid form, but it no longer resembles bamboo. Instead, it resembles silk-like fibers, smooth, flexible, extremely soft. This is why bamboo clothing feels so different from traditional cotton. The fibers emerging from the regeneration baths are exceptionally uniform. Unlike cotton, which naturally varies from fiber to fiber, regenerated cellulose can be engineered with remarkable consistency. The endless strands travel through multiple washing stages. This step is critical. Residual chemicals must be removed. Acid residues, reaction byproducts, processing compounds, everything must be washed away. Thousands of gallons of water circulate through the system. The cleaner the fibers, the better the final product. The strands then pass through stretching systems. Machines pull the fibers under carefully controlled tension. This aligns the cellulose molecules, improves strength, enhances durability, and helps create the performance characteristics consumers expect. The fibers continue through drying tunnels, warm air removes moisture, the strands become lighter, stronger, more stable. What began as a bamboo forest now looks like giant ropes of silky white fiber, and yet the transformation is still incomplete, because fibers aren't fabric, not yet. The material must still be converted into yarn, then woven or knitted, then dyed, then cut and sewn into clothing. But before that happens, another question emerges. A question that sits at the center of the entire bamboo clothing industry. If the bamboo was dissolved completely and rebuilt into something new, can it still be called bamboo? And that's where one of the most controversial debates in modern sustainable fashion begins. Up to this point, the story sounds simple. A bamboo plant is harvested, its cellulose is extracted, new fibers are created, fabric is produced, clothing reaches the store, case closed. But this is where the story takes its biggest turn. Because the label says bamboo, the marketing says bamboo, the advertisements say bamboo. Yet many textile experts would describe the material very differently. They would call it rayon or viscose. And that distinction has become one of the most controversial topics in modern sustainable fashion. Here's why. When people hear the phrase bamboo fabric, they imagine fibers taken directly from bamboo. Something similar to how cotton comes directly from a cotton plant, or how linen comes directly from flax. The assumption seems reasonable. After all, the product is called bamboo clothing. But the reality is more complicated. Remember what happened inside the factory. The bamboo wasn't simply processed, it was dissolved. The original plant structure disappeared completely. The natural fibers were broken apart. The cellulose was extracted, converted into a liquid, then regenerated into entirely new fibers. By the time the process was finished, the original bamboo fibers no longer existed. Only the cellulose remained. And cellulose isn't unique to bamboo. Trees contain cellulose. Cotton contains cellulose. Many plants contain cellulose. The final fiber is created not by preserving bamboo fibers, but by rebuilding cellulose into a new form. That's why regulatory agencies began paying attention. In the United States, the FTC, the agency responsible for consumer protection, started investigating bamboo textile marketing claims. They found that many products advertised as bamboo were actually rayon made from bamboo. The distinction matters because consumers often interpreted bamboo as a natural fiber, something mechanically processed, something closer to raw plant material. In reality, most bamboo fabrics were chemically regenerated fibers. The FTC eventually issued warnings to numerous companies. Some retailers paid significant penalties. Others were required to change how they described their products. The agency's position was straightforward. If the fiber is rayon, it should be labeled rayon. Even if the cellulose originally came from bamboo, suddenly an entire industry found itself caught between science and marketing. Because the word bamboo sold products, the word rayon did not. And yet the manufacturing process clearly resembled rayon production. Consumers became confused. Manufacturers became defensive. Environmental groups entered the debate, and the conversation expanded beyond labels. It became a discussion about sustainability itself. Because bamboo's environmental reputation wasn't entirely undeserved. The plant really does grow quickly. It really does require less water than cotton in many regions. It really can regenerate after harvesting. Those advantages are real. But here's where things become complicated. The environmental footprint of bamboo clothing isn't determined solely by the plant. It's also determined by the factory. The chemicals, the energy requirements, the wastewater treatment systems, and the efficiency of the manufacturing process. A bamboo forest may be highly sustainable. That doesn't automatically mean every bamboo fabric is. The factory matters a lot. And that's where another technology enters the story, one that many experts believe could reshape the future of bamboo textiles: lyocell. Unlike traditional viscose production, lyocell uses a different solvent system. In modern facilities, more than 99% of the solvent can often be recovered and reused. The process generates far less waste, uses fewer hazardous chemicals, and is often considered one of the most environmentally advanced cellulose fiber technologies available today. Some bamboo fabrics are now produced using lyocell technology. These products are frequently marketed as premium sustainable alternatives, but they remain a relatively small part of the market. Most bamboo clothing sold globally is still produced using viscose-based methods. And that's the hidden truth. The biggest question isn't whether bamboo clothing starts as bamboo. It does. The question is what happens afterward. Because the journey from plant to fabric involves one of the most complete material transformations in modern manufacturing. The bamboo enters the factory as a plant. It leaves as an engineered textile. And the difference between those two things is much larger than most consumers realize. The shirt may have started in a bamboo forest, but its story is really the story of chemistry. At this stage, the bamboo has already undergone its most dramatic transformation. The forest became pulp, the pulp became liquid, the liquid became fiber. But consumers don't buy fiber, they buy clothing. And turning those regenerated cellulose fibers into shirts, pants, underwear, and bedding requires an entirely new manufacturing process. The dried fibers leave the chemical plant in large bales. Each bale contains thousands of kilometers of filament. From there, the material enters textile mills, factories dedicated to transforming fibers into yarn. The process begins with spinning. Machines twist the fibers together under controlled tension. Thousands of individual filaments become a continuous thread. The amount of twist affects everything: strength, softness, durability, even how the fabric feels against human skin. Too little twist and the yarn becomes weak. Too much and the fabric feels rough. Engineers carefully balance these characteristics depending on the final product. A bamboo t-shirt requires different properties than bamboo bed sheets. Once the yarn is produced, it moves to knitting or weaving machines. Most bamboo clothing uses knitting, not weaving. Knitted fabrics stretch more easily, they feel softer, they drape naturally. Exactly the qualities consumers expect when buying bamboo apparel. Modern knitting machines operate at astonishing speeds. Thousands of needles move simultaneously, creating fabric continuously, hour after hour, day after day. The resulting material emerges as giant rolls, sometimes weighing hundreds of kilograms, but the fabric still isn't finished. At this point, it's usually white, colorless, and not particularly attractive. That's where dyeing begins. Huge dyeing vessels immerse the fabric in carefully formulated solutions. Temperature, pressure, time, everything must be controlled precisely. Consumers expect consistent colors. The black shirt purchased today must match the black shirt purchased 6 months later. Factories invest enormous resources to ensure color consistency. After dyeing comes finishing. This stage can dramatically alter how fabric behaves. Some finishes improve softness, others enhance moisture management. Some reduce wrinkles, others improve durability. The fabric that finally reaches clothing manufacturers may look completely different from the raw material that entered the finishing plant. The rolls are then shipped to garment factories. Here, computer-controlled cutting systems layer dozens of fabric sheets together. Automated cutters move across the material with incredible speed. Thousands of garment pieces can be cut in a single shift. Front panels, sleeves, collars, waistbands. Everything is optimized to minimize waste. The cut components travel to sewing lines. Workers and automated systems assemble the garments step by step. A t-shirt may pass through dozens of sewing operations before completion. Pants often require even more. Seams are inspected. Labels are attached. Threads are trimmed. Finished garments undergo quality control inspections before packaging. Eventually, the clothing enters distribution centers, then retail stores, then online warehouses, then consumers' homes. And that's where the story usually ends, at least for most people. They see a shirt, a pair of pants, a set of bamboo sheets, something soft, comfortable, eco-friendly. But now you know something most consumers don't. You know what happened before the clothing ever reached the shelf. And that brings us back to the promise that made bamboo clothing famous in the first place. Sustainability. Is bamboo clothing sustainable? The honest answer is complicated. The bamboo plant itself is remarkably efficient. It grows quickly, regenerates naturally, requires relatively little land compared to many alternatives. Those advantages are real. But sustainability doesn't begin and end in the forest. It continues through every stage of manufacturing: energy consumption, chemical recovery, wastewater treatment, transportation, factory efficiency. All of these factors influence the final environmental footprint. A sustainably grown bamboo plant can still pass through an inefficient manufacturing process. Likewise, advanced factories using closed-loop technologies can dramatically reduce environmental impact. The label alone rarely tells the full story. And that's the final reveal. Most consumers think bamboo clothing is simply about bamboo, but it isn't. It's about transformation. One of the most extraordinary transformations in modern manufacturing. A hard woody stalk becomes a soft fabric. A construction material becomes clothing. A forest product becomes a fashion product. And almost every step in that journey depends on science, chemistry, engineering, textile technology. The shirt may have started as bamboo, but the fabric you're wearing is the result of one of the most sophisticated cellulose transformations ever developed. The label says bamboo. The factory tells a much bigger story. And now, every time you see bamboo clothing advertised as natural, sustainable, or eco-friendly, you'll know the real story hidden behind the fabric. That's the process. We reveal how things actually work, one story at a time. If there's something you'd like us to explore next, let us know. Until then, trust the process.